Okay, here you might wondering, are we going too far? Because we can simply use an array to implement the same thing. In that case, we're going to have an array um, uh, where we can put each of the items into that array like this. The first elements, item 1, second, item 2, item 3, item 4, and so on and so forth. So why don't we just use this array? It's much simpler rather than we have to setting this next pointer all the time. Yeah, that's right. Um, this could be one of the implementation. However, well, in case that we need to insert an item 5 after the item 2, if we're using an array, what we have to do is we have to move um, item 3 and 4 by one position. And in that case, we have empty space for the item 5. So we can put it here. You will see what we're doing is like this. We move the item um, to the tail of that array. Then we have an empty space for item 5 here. So this might be okay because we don't have too much items there. However, imagine that we have a very long list. We have a large collection of items. So every time we have to insert an item, we have to do this moving. So it's costs a lot of time and it's not that efficient. So, yeah, that's it. And sometimes we have to do the deletion. So for delete, for example, if we have to delete one item, we will move those items forward uh, towards the head of that array. So it also costs a lot of time. It's not efficient. However, the linked list way might be much easier and much more efficient than the array. Here is the examples we had. We have 4 items there as a linked list. To insert item 5, we just have to break this link between the item 2 and item 3. Then we can point the next pointer to item 5. Then and then we can set the next pointer of item 5 to item 3. In that case, we don't have to do too much. It's just changing the pointers. It's much easier. We don't have to change this part. We don't have to change this part, and they'll just stay where they are inside the memory. And after that, you will see a new updated linked list is there. So you can access this list in the same way we had. And here is the code which shows that you could see here we are adding a new item 5, and then here is the part where updating the links of the item 2 and item 5. So as we have shown in previous slides, and after that we can use the same function without changing anything because the function doesn't matter how the items are linked. So every time it's just going to visit the item from the first item of the linked list and to the end of that linked list. So using the same function, we will see the result has been updated. Here we have item 5 already, and the next item of the pointer of the item 2 has been pointed to the item 5, and the item 5 is pointing to the item 3 there. So here after the insertion, the linked list has already been updated. And what you have to do is just to update these two links, these two pointers. It's much easier than the array version. And here is a completed code of that. From here you could see it's just stay as the same as we had in the previous example. And here is the updated part. Okay, to delete a node from a linked list, it's also easy. For example, if we have to delete item 2, we just have to break these two links. That means we can change the pointers by skip the item 2 by setting the next pointer of item 1 to the item 5 directly. So in that case, the item 2 will be excluded from this linked list.